So in this slide, this is actually the Cleveland water supply. And it goes through and tells you each step of how water is treated when it comes in before you can use it as drinking water. And so the first one is it says debris removal, or it's basically like a rough filtration. So when people dump leaves in the gutter and a lot worse things, and they collect them and they take those out of the water first, then they mix it up well. That's the second part. And the third part is they add some bacteria and they add some chemicals that cause it flocculation. So it takes all the little impurities and makes it all clumped together. So it flocculates, which just means that it makes all these impurities kind of stick together. And then the third part is you wait for that to settle. Sedimentation. Look, that was just like our sedimentary rocks, right? Or our geologic cores. They all go together. They're all the same kind of process. So after sedimentation, then it goes into filtration. And the last one is the one they all remember when they turn on the tap. It's actually where they add the chlorine and disinfected. I just can't see it from this distance. All right. So after you've talked about this is what a big, what a big city does, or even a small city. So after you've talked about that, and after you can either even take a water treatment in your town, take a tour, or there's lots of videos online that actually take you through tours of water treatment, then you say, okay, now that you know how big cities do it, you're going to compete and make the best water treatment that you can in the classroom. The way you're going to do that is on the next slide with clearing the water. Now you can see that you've seen. Now you can say that you've seen it. Okay. So here's the one where my lovely assistant, made two different versions of a water filter, right? And there are lots of things in the kit like sand and gravel and activated charcoal and coffee filters and cotton and all kinds of things. So they get to pick what they're going to use, and then they create it. And this is the STEM part, because they're thinking about how would this affect based on all that flocculation and all the things we talked about. So the first thing you do is that you take and you prime it with about 90 mils of water, and you wait for it to go through. Sometimes it just has to make sure that everything gets wet. This one's sort of smoking a little bit because the little powder is poofing. That's a scientific word too, poofing. All right.
Question for the age range for this kit?
This one, most of our essentials, what we call essentials, is for the middle school, but you can certainly, with supervision, take it a little lower, or you could take it a little higher, but really this is more of a middle school kit. All right? So now it's gone through, it's been primed, it's nice and wet. You can take the sample fluid, and as you see there's a few things that you could actually try. You could do clay, like make it a turbid solution and see how clear it is at the bottom. You could even do it if you have the equipment, this will be more high school, you could put it on a spectrophotometer and see how turbid it is, and you could actually measure it. Or you can do red food coloring, which comes in the kit, and pour into each of them. That's what I'm going to do here. And I'm not measuring it out, so I'm not being very scientific right now. Right? Give it a minute. And or you could actually put some bacteria. You could buy some bacteria, or if you think something's kind of cruddy and you want to test it at the end and take the water and put it on a plate and see how much bacteria is left. That's another thing that you could test. So these are all ways that you could judge them, or they judge each other to see who has the best water treatment system that they've designed. Then, of course, the best thing to do is to have them go back, try to modify what they've done and recreate it, or recreate what they think is going to be better. It's always about betterism, right? And then they can redesign and run it again and actually compete in a first or second trial. Another thing that you can do, along with how is it, what is the clearest, is what you normally think of at the bottom, is how fast does it happen, right? Because you don't want, as a water treatment facility, for it to take days for it to filter. So it might also be, what's the rate of filtration? How fast does it go through, right? And another part of that is that these materials cost money, and you can actually design whatever money you want to say that it is, right? And see if they can design it economically as well. How much are they using? What are they using? And those kind of things. All right? You're also introducing different terminology, like you can explain what distillation is, you can explain what ion exchange is, and what flocculation is. All right. Questions about that? And it's going through, and as you can see, this one is actually running faster. This one is kind of not running yet, but it will. If I left this overnight, and I could, what you're going to find, and I'm going to tell you the secret, but you can't tell your students, right, is that this one has activated charcoal in it, which was what was kind of poofing and smoking. It's not really smoking. And it will actually remove the red food coloring. But they'll find that out by trial and error. Okay? All right.
Can we see a more close-up?
Maybe. So that's one of them, and you can kind of see the charcoal that's kind of floated up to the top on that one versus this one. And it's just kind of hanging there. So, okay. These are taking a little bit longer.